X-rays are electromagnetic waves with wavelength length 0.1 Armstrong to 100 Armstrong. X-rays were discovered by Roentgen. X-rays travels in a straight line. This shows reflection, refraction, interference, diffraction, polarization, and do not reflected by electric and magnetic fields. Long exposures of X-rays is injurious for human body. X-ray shows photoelectric effect. Now uses of X-rays. In medical sciences, X-rays are used in surgery for the detection of fractures, diseased organs, foreign matters like bullet, stones, etc. They are used in the treatment of cancer and skin diseases. In engineering, X-rays are used in detecting faults, cracks, flaws, and gas pockets in finished metal products and in heavy metal sheets. In scientific work, X-rays are used in studying crystal structure and complex molecules. In custom department, X-rays are used in custom department for the detection of bent materials kept hidden. Satellites are natural or artificial bodies revolving around a planet under its gravitational force of attraction. Moon is a natural satellite while InSat B is an artificial satellite of Earth. Period of revolution of satellite revolving near the surface of Earth is 1 hour 24 minutes or 84 minutes total. Geostationary satellite revolves around the Earth at a height of 3600 km. The orbit of geostationary satellite is called parking orbit. Geostationary satellite revolves in equatorial plane from west to east. The time period of rotation of geostationary satellite is 24 hours. Earth rotates from Earth rotates on its axis from west to east. This rotation makes the sun and stars appears to be moving across the sky from east to west. Geostationary satellite is used to telecast TV programs from one part of world to another. Polar satellite revolve around the Earth in polar orbit at a height of 800 km. These satellites are used for weather forecasting and mapping. All the quantities which are used to describe the laws of physics are called physical quantities. Physical quantities are of two types: fundamental quantities and derived quantities. Physical quantities which are independent of each other are called fundamental quantities. For example, length, mass, time. Physical quantities are obtained with the help of fundamental quantities are called derived quantities. For example, force, energy, and speed. The standard amount of physical quantity chosen to measure the physical quantity of the same kind is called physical unit. Physical unit of length is meter. Physical unit of time is second. Physical unit of mass is kilogram. Physical unit of area is square meter. Physical unit of volume is cubic meter. Physical unit of velocity is meter per second. Physical unit of acceleration is meter per second square. Physical unit of density is kilogram per meter cube. Physical unit of momentum is kilogram meter per second. Physical unit of work and energy is joule. Physical energy of force is Newton. Physical energy of pressure is Pascal or Newton per meter square. Physical unit of frequency is Hertz. Physical unit of power is watt. Physical unit of weight is kilogram. Physical unit of viscosity is poise. Physical unit of surface tension is Newton per meter. Physical unit of heat is Joule. Physical unit of temperature is Kelvin. Physical unit of absolute temperature is Kelvin. Physical unit of resistance is ohm. Physical unit of electric current is ampere. Physical unit of electromotive force is volt. Physical unit of electrical conductivity is ohm per meter. Physical unit of electric energy is kilowatt hour. Physical unit of magnetic intensity is Oersted. Physical unit of charge is coulomb. Physical unit of magnetic induction is Gauss. Physical unit of luminance intensity is candela. Physical unit of sound is decibel. Physical unit of impulse is Newton second. Physical unit of angular velocity is radian per second. Physical unit of power of lens is dioptre. Electric charge. It is basic property associated with matter due to which it produces and experiences electrical and magnetic effect. The total charge acquired by a body is an integral multiple of magnitude of charge on a single electron. This principle is called quantization of charge. Magnitude of charge on one electron is minus 1.6 10 raised to power minus 19 coulomb. Charges on an electron is n into 1.6 10 raised to power minus 19 coulomb. Magnitude of charge on one proton is plus 1.6 10 raised to power minus 19 coulomb. Similar charges repel each other while opposite charges attract each other. The SI unit of charge is coulomb. Now conductors. Conductors are those materials which allow electricity to pass through themselves. Metals like silver, iron, copper and earth acts like a conductor. Silver is the best conductor. Now insulator. Insulator are those materials which do not allow electricity to flow through themselves. For example, wood, paper, mica, glass, ebonite and are insulator. Now electric current. Electric current, it is defined as the rate of flow of charge or charge flowing per unit time. Its unit is ampere. It is a scalar quantity. If Q is the amount of charge flow through conductor in T time, then electric current I is given charge upon time, or Ne upon T, where N is equal to number of electron flowing through the conductor. Direction of electric current is in opposite direction of flow of electrons. A lightning conductor is fixed to tall buildings to protect from the destructive effects of lightning. An electric bulb make a bang when it is broken because there is a vacuum inside the electric bulb. When the bulb is broken, air rushes at great speed from all sides to fill vacuum. The rushing of air produces noise generally referred as the bang. Now potential difference. The amount of work done required to move a charged particle from one point to another point is electric field is called potential difference. It is given by V is equal to W upon Q volt. Now Ohm's law. At constant physical conditions of any conductor, the current flowing through conductor is directly proportional to the potential difference across it. It is given as I is equal to V upon R, where R is the resistance. If a wire is stretched or doubled on itself, its resistance will change, but its specific resistance will remain unaffected. On increasing the temperature of metal, its resistance increases. On increasing the temperature of semiconductor, its resistance decreases. On increasing the temperature of electrolytes, their resistance decreases. Now light. It is radiation which make our eyes available to see the object. Its speed is 3 into 10 raised power 8 meter per second. It is the form of energy. It is a transverse wave. It takes 8 minutes 90 seconds to reach on Earth from the Sun, and the light reflected from Moon takes 1.28 seconds to reach Earth. Now reflection of light. When ray of light falls on a boundary separating two media comes back into the same media, then this phenomena is called reflection of light. These are two laws of reflection. First, the incident ray reflected ray and the normal to the reflecting surface at the incident point all lie in the same plane. Second, the angle of reflection is equal to angle of incident. Now reflection by plane mirror. The image is virtual and literally inverted. The size of image is equal to that of object. The object moves towards the plane mirror with speed v relative to the object moves towards with a speed 2v. To see his full image in a plane mirror, the person requires a mirror of at least half of his height. The number of images formed by a plane mirror is n is equal to 360 degree by 30 minus 1, when 360 degree by 30 is even number, and n is equal to 360 degree by theta when 360 degree by theta is odd number. Now spherical mirrors. Spherical mirror are of two types, concave mirror and convex mirror. Image formed by convex mirrors is always virtual, erect and diminished. Image formed by concave mirrors is generally real and inverted. Image formation by concave and convex mirror is shown separately. Human eye. It is an optical instrument like camera. It forms the real image of the object on retina of the eye. Least distance of distinct vision is 25 centimeter. Now defects in eye. First one is myopia. Myopia is also known as short-sightedness. A short-sighted eye can see only nearer objects. Distant objects are not seen clearly. This defect can be removed by using concave lens of suitable focal length. Second is hypermetropia, also known as long-sightedness. A long-sighted eye can see distant objects clearly, but nearer objects are not clearly visible. This defect can be removed by using convex lens. Presbyopia. In this defect, both near and far objects are not clearly visible. It can be removed by using bifocal lens. Now, astigmatism. In this defect, eye cannot see horizontal and vertical lines clearly. This defect can be removed by using suitable cylindrical lenses. The orderly arrangement of electromagnetic waves in increasing or decreasing order of wavelength or frequency is called electromagnetic spectrum. The range varies from 10 raised to power 12 meter to 10 raised to power 4 meter, from gamma rays to radio waves as shown in the figure. First one is gamma rays, then X rays. Third one is ultraviolet rays. Fourth one is visible rays. Fifth one is infrared rays. Sixth one is microwaves. Seventh one is short radio waves. Eighth one is television and FM radios. Ninth one is AM radio. and 10th one is long radio waves. Now order of visible rays are: first one is violet, second one is blue, third one is green, fourth one is yellow, fifth one is orange, and sixth one is red. Newton's law of motion. First law: every body maintains its initial stage of rest or motion unless an external force acts on it. It is also called Galileo's law or law of inertia. Application of first law. A person standing in a bus falls backward when bus start moving suddenly. If a moving bus stops, then the passenger falls in forward direction. When we shake tree vigorously, its fruits and leaves fall down. Now second law. Force acting on an object is directly proportional to the product of mass of the object and acceleration on it. Force is equal to mass of object multiplied by acceleration. Its application. In a high jump athletic event, the athletes are made to fall either on a cushioned bed or a sand bed. A cricket player moves his backwards on catching a fast cricket ball. Now third law. For every action there is an equal and opposite reaction. Application. While walking, a person presses the ground in the backward direction. This is action by his feet. The ground pushes person in forward direction, which is reaction with equal force making the person to walk. A swimmer pushes the water backwards with a force. The water pushes swimmer forward with the same force. Hence the swimmer swims. It is difficult to walk on sand because on pushing sand get displaced and the reaction from sand ground is small. Now inertia. The unwillingness or inability of an object to change its state of rest or uniform motion along a straight line is called inertia of object. Momentum. Momentum measures the quantity of motion possessed by a body. It is defined as the product of mass and velocity of the body. If a body of a mass m moves with velocity v, then momentum p is given by p is equal to mv. SI unit of momentum is kilogram meter per second. Archimedes principle. When a body is immersed partially or wholly in a liquid, there is an apparent loss in weight of the body, which is equal to the weight of the liquid displaced by the body. The weight of water displaced by an iron ball is less than its own weight, whereas weight displaced by immersed portion of a ship is equal to its weight. So a small ball of iron ball sink in water, but large ship float. A fat person will quickly learn the swimming as compared to slim person because he will displace more water, so he will be more balanced. Hydrogen filled balloon float in air because hydrogen is lighter than air. A person can lift more weight in water. Now laws of flotation. If the density of material of body is equal to the density of liquid, the body floats fully submerged in liquid in neutral equilibrium. When the body floats in neutral equilibrium, the weight of the body is equal to the weight of the displaced liquid. The center of gravity of the body and center of gravity of the displaced liquid should be in one vertical line for the condition. Now density. It is defined as mass per unit volume. Relative density is measured by hydrometer. The density of seawater is more than the normal water. The density of iron is more than that of water but less than that of mercury. So a solid chunk of iron sink in water but float in mercury. If ice floating in water in a vessel melts, the level of water in the vessel does not change. When a ship enters in a sea from river, it raises a bit because the density of saline water is higher. Now surface tension, the property of a liquid by virtue of which it tries to minimize its free surface area, is called surface tension. Surface tension decreases with rise in temperature and becomes zero at critical temperature. The surface tension of clean water is higher than that of a soap solution. Formation of lead shot spraying result in coldness. Flotation of needle on water, dancing of camphor on water are based on surface tension. Raindrop form spherical shape due to surface tension. When kerosene oil is sprinkled on water, its surface tension decreases, due to which the excess of mosquitoes floating on the surface of water die due to sinking. Cohesive and adhesive forces. Forces of attraction applied between molecules of same substance is called cohesive force, while attractive force between molecules of different substance is called adhesive force. Capillarity. The phenomenal rise of or depression of liquid in a capillary tube is called capillarity. A piece of blotting paper soaks ink because pores of blotting paper serve as capillary tube. The oil in the wick of a lamp rises due to capillary action of threads in wicks. The root hair of plant draws water from the soil through capillary action. Now viscosity. It is the property of a fluid by virtue of which an internal friction force acts between its layer when it is in motion. Resistivity. Resistivity of a conductor is defined as the resistance of a conductor of unit length and unit area of cross section. Its SI unit is ohm meter. Reciprocal of resistivity of a conductor is called its conductivity. Its unit is mho per meter. The heating effect of electric current is known as Joule's law of heating. Electric bulb, electric kettle, heater, and other devices work on the basis of heating effect of electric current. Ammeter is a device which is used to measure electric current. It is connected in series. The resistance of an ideal ammeter is zero. The voltmeter, it is a device used to measure the potential difference between 2 points in a circuit. It is connected in parallel to the circuit. The resistance of an ideal voltmeter is infinite. Now fuse wire. Fuse wire, it is a small conducting wire of alloy of copper, tin, lead having low melting point. So it is protective device used in series.